Greetings, boys and girls. In today's video, we are going to be reviewing how to classify two-dimensional shapes. Let's start this video off with a little joke. Why was the math book sad? Well, it's because he had too many problems. Too many problems. And thankfully, we're not going to have too many. This is, it seems like it might be quite a few pages, but it's not going to be too many problems today. So let's get right into it. Let's review what a polygon is. Well, it's a closed shape where all the sides are straight. There are no intersecting lines and no curves. What we mean by no intersecting lines is you're not going to have something like this and call that a polygon, okay? Because these lines are intersecting in the middle. But you may have a three-sided shape, which would be a triangle. I'll give you some examples. A four-sided shape, that would be a quadrilateral. You can have a five-sided shape, that would be a pentagon. A six-sided shape would be a hexagon. A seven-sided shape would be a heptagon. You see some examples of those. An eight-sided shape is an octagon. A nine-sided shape is a nonagon. And a 10-sided shape is a decagon. Now, there are other shapes that will have more sizes, but those are the common ones. And really, we spend a lot of time focusing on two big bucket areas, so the triangles and the quadrilaterals. So let's look a little bit closer at triangles. In fourth grade, we typically will describe triangles by their angles, okay, because we started measuring angles, and we know that anything less than a 90-degree angle is considered an acute angle. So you might have a triangle that has three acute angles inside. And if you have that, that is called an acute triangle. Okay, all three angles are going to be less than 90. Now, I wonder, do you guys remember the three angles inside of a triangle? What do they add up to be? Well, they add up to be 180 degrees. Hopefully you remember that. So an acute triangle has three angles that are all less than 90 degrees. Then you have a right triangle. Inside of a right triangle, one of those angles is going to be a right angle. The other two angles are going to be acute angles. Just writing that down. And that's because you know that the total is going to be 180. So 180 minus 90, because a right angle is 90, means that you have 90 degrees left for two more angles. So you cannot have another angle that's going to be greater than 90 or even greater than 89 inside of there. Alrighty. And then the last kind of triangle we have is an obtuse triangle. Obtuse triangles have one angle that is obtuse. The other ones are going to be acute. Okay? So a triangle is going to have at least two acute angles. It might have three acute angles. In that case, it is an acute triangle. Or it might have one right angle. That would make it a right triangle. And it might have one obtuse angle, which would make it an obtuse triangle. Let's look at some special quadrilaterals. Now, a quadrilateral is simply a four-sided shape. Okay? And there are some really special ones that you'll notice. Okay, so the first one you can see is a parallelogram. It has two pairs of parallel lines. The opposite sides are equal. So that means this is the same length as this. This opposite side is the same length as that one. And their opposite angles are equal. Now notice it doesn't say that a parallelogram has two acute angles and two obtuse angles. Therefore, a rectangle could also be considered a parallelogram. But a rectangle is a special parallelogram. What's so special about it, you might ask? Well, look, it's a parallelogram with four right angles. Okay? And when we look on this side, it's still saying opposite sides are equal and parallel. All angles are right angles. Okay, all of the angles measure 90 degrees. We also have a square. Now, a square is a special kind of rectangle. Okay, look here. It tells us it's a rectangle with all sides equal in length. Now, we still see that all the opposite sides are parallel. We still see that all the angles are right angles, but all the sides are equal. So that is a special rectangle. Okay, now let's look at the rhombus. The rhombus is a parallelogram with all sides equal in length. Now remember, the square had all sides equal in length as well. But a rhombus, you notice that it has a little slant when we're looking at these pictures. Okay, so the opposite sides are parallel, all the sides are equal, opposite angles are equal, and diagonals bisect each other at right angles. So when you draw a line, you see how it intersects at 90-degree angles. You will notice the same thing in a square. So that is something to keep in mind. That rhombus also intersects at 90-degree angles. That's something we didn't really talk about before, but hey, this is something else to keep in mind. But the big thing we need to know is that a rhombus has 4 sides that are all the same length, and it's a quadrilateral. And rhombuses are in the parallelogram. They can also be considered parallelograms, but they're not always considered a square. Some squares, like a square is a special kind of rhombus, but you don't have to have 90 degrees angles to be a rhombus. Okay? All right, and then we'll talk about, we're not going to really focus on this kite one, but we will talk about the trapezoid. So it's a quadrilateral, means 4 sides, and it has 1 pair of parallel sides. That's all it has to have. So look, this line and that line are parallel. Those sides are parallel. Look on this one. It's also the top and the bottom that are parallel. That's the big idea with a parallelogram. Sorry, with a trapezoid. That it has 1 set of parallel lines. Okay? So we're going to move right into our first question. Which figure cannot have parallel line segments? So our options are squares, pentagons, triangles, and trapezoids. Okay, so something that cannot at all have any kind of parallel line segments. So let's start with the square. I'm looking at the square, and look, right there, I already see I have parallel line segments. Okay? The 2 opposite line segments are going to be parallel. So that answer choice would not work. Now, the next one says pentagon. Right here, I have a picture of a pentagon. And really, none of these line segments are ever going to intersect, so they would be parallel. However, the definition of a pentagon is just a 5-sided shape. So I can draw a pentagon that looks like a house. And guess what? I'll have parallel line segments. Do you see that right there? So don't just get stuck thinking that a pentagon only looks one way, because then you might select that as an answer choice. So we're going to cross that one out, because I now have an example of a pentagon when I would have parallel line segments. Then they said, I'm going to skip H and go to trapezoid. I wanted to go to trapezoid because look right here, I have a trapezoid. My top and bottom line segments are parallel, okay? And that's the definition of a trapezoid. It has 1 set of parallel line segments. So that can't be it. Now it looks like our answer has to be a triangle. But now we're going to prove. I put pictures of a couple of triangles on here. The definition of parallel lines are that they'll never, ever, ever touch. Well, guess what? A triangle, it's 3 lines. All 3 lines have to touch each other at some point. So this line is touching this line, and that'll eventually touch this one. So those are not parallel. This one and this one, they intersect. These intersect. These intersect. Every triangle you look at, the 3 lines are going to intersect. So in a triangle, by definition, you cannot have parallel line segments. So H would be our answer. Let's go on to the next problem. Which statement is true about a pentagon is true? Okay, it must have parallel sides. No. Here's an example of a pentagon where none of the sides are parallel. Now the one I drew on the last example, in the last problem, that does have parallel line segments. But it doesn't, a pentagon does not by definition have to have parallel sides. Okay, so that is not it. Answer choice G says it must have more vertices than sides. Well, let's count the vertices. 1, 2, 3, 4, 5. And the sides, 1, 2, 3, 4, 5. So that's not true because they have the same amount of vertices and the same number of sides. So G would not work. It must have no right angles. All right, I'm going to draw that house example of a pentagon again. Because remember, by definition, pentagon just has 5 sides. Well, look, if I draw something that looks like the house, I have 2 right angles right at the bottom. Okay? So, therefore, that is not right. Because this is a 5-sided shape. Okay, 1, 2, 3, 4, 5. And then the last one says it must have 5 sides. Yes, that is our answer. Because that's what a pentagon does, is it has 5 sides. That's what makes it a pentagon, 5-sided shape. Okay, go ahead and select your answer. Can you also draw this example of the pentagon so that you remember why answer choice H did not work? Okay, go ahead and pause the video if you need some more time to draw it. Otherwise, we're going to move on to the next problem. Okay, Peter wants to classify the figure below as many ways as possible. So I put on here some of those images we saw not too long ago so that we can just remember. So look. Here's a rectangle. We remember that a parallelogram can also be, a rectangle can also be a parallelogram. Okay? It doesn't mean that every parallelogram is a rectangle, but every rectangle is also a parallelogram. So I'm looking for rectangle, parallelogram. Okay, now I'm looking at this image. That image, which looks exactly like that rectangle over there, it has 2, the opposite sides are the same length, has 4 right angles. But I can look at that and tell that it's not, they don't all have the same length of the sides. Okay, let me repeat that. The sides are not the same length, so it's not a square and it's not a rhombus. Both of those have sides that are the same. So I'm going to look, oh, square can't be this one. Rhombus can't be that one. Okay, so now I've gotten rid of 2 answer choices. Now, I'm looking at this image and it has 1, 2, 3, 4 sides, which means it's a quadrilateral. All right. Oh, look. Answer choice D filled everything. Now, a trapezoid says it has one set of parallel sides, but this has these sets that are parallel and these sets that are parallel, so it is not a trapezoid. So therefore, answer choice D is the best. Okay, let's go to the next problem. What is the name of a quadrilateral that always has 4 right angles? Okay, now I'm looking at the picture. I see 4 right angles. There's 1, 2, 3, 4. Oh, this one does not have 4 right angles. I don't see any right angles there. None there. And I see 1, 2, 3, 4. So I'm looking for a rectangle or a square as my answer choice. And it looks like right there, number 11, answer choice B, that's what we're looking for. Now it helps to draw images so that your mind has something to think about instead of just trying to, it's good to have a visual to help you see what you're supposed to be looking at. Okay, we're going to change things up for a moment. Do a quick joke. Why did the class clown take a computer to school? Why do you think he took the computer to school? His mom told him to bring an apple for the teacher. And by the way, that's a really nice kind of apple if a teacher gets that. Okay, let's get into this problem. What is the name of the figure shown below? Well, looking at this image, they have some little blue lines on here. So I see right here, that's the same length as, those are the same length, and then these two are the same length. Okay? So I'm erasing that. So the opposite sides are the same length, 4-sided shape. This has to be a parallelogram. Now, let's remember why it cannot be a rhombus. A rhombus has equal side lengths all the way around. Can't be a trapezoid because trapezoids have only one set of parallel lines. And it can't be a square because it doesn't have 90-degree angles. And what else? Sides are not equal length. Okay, so parallelogram is our best answer choice. Let's look at 13. How many acute angles are in a right triangle? So let's look at our right triangle, which is right here. How many acute angles do you see? 1 and 2. All right, let's look at another one together. This is a multi-step problem. Which triangle has one right angle and no obtuse angles? Okay, well, this is really nice because look, they gave us a symbol to say there's a right angle. Now we know we can't have any obtuse angles in there because 180 minus 90 is 90. So if I take that right angle, I can't have an angle that's larger than 90 also. So triangle PQR is going to be the one that is the right triangle with no right angles. And they put that symbol that told us this is a right angle. Okay, last question. Which quadrilateral can have two pairs of parallel sides, all sides with equal length, and no right angles? So I'm thinking about a square. Square by definition has 4 right angles, even though the lengths are the same. Okay, a rhombus by definition has 4 sides of the same length, and then 2 sets of parallel lines, 2 sets of parallel sides, and doesn't have to have any right angles. So rhombus would be our better choice. Now, going back to this trapezoid, let's look at this trapezoid. A trapezoid, it has only one set of parallel lines. So that's why that didn't work. And then finally the rectangle. Ooh, there's 2 things that make this one not work out. One are these 4 right angles, and the other is the fact that all the sides are not the same length. Okay, so rhombus was the best answer choice there. Okay, last joke of the week. What do you call a king who is only 12 inches tall? You don't just call him short, but you call him a ruler. Get it? A ruler. He's only 12 inches tall. All right. Well, I hope you enjoyed this video, and I hope it made sense and clarified some things. We just had a chance to review classifying two-dimensional shapes. Take care. The rest of your homework is on your own.